Okay, I think folks are still streaming in. I suspect a lot of talks have run slightly late, so that's fine. We will actually make a proper start in a couple of minutes. Those of you who are in Kevlin's talk just now, he mentioned legacy a few times. I now have a fairly new appreciation of the word legacy since becoming a Hamilton fan. Part of Hamilton is him saying, legacy, legacy, what is a legacy? It's planting seeds in a garden you never get to see, from which we understand that Hamilton was a consultant. So he was writing all this code and then riding off into the sunset and letting other people manage the mess that he'd left. Okay, on your agendas, you will have seen that this talk is notionally by me, and in an hour and 20 minutes, there's another talk by Bill. We noticed this and thought, this is silly. A C# 7.0 talk followed by a 7.1 and 7.2 and maybe more talk. We thought it would be much better if we presented together. So the format that we've sort of discussed this morning is I will present most of the code for this talk, and occasionally Bill will ask me questions as if he were you. Do not let this stop you from asking questions as well, okay?
As if you were me.
Yeah, and one thing that Bill can do is, while I am looking at the keyboard, so I will be sat for most of the time, while I'm looking at the keyboard, Bill can see any hands, but if Bill hasn't seen a hand within a few seconds, just shout, okay? We're all friends, it's all fine, no one will consider that rude. So please do shout if you have any questions, because chances are someone else is thinking the same thing. But hopefully Bill will ask you questions and I will ask Bill questions of sort of motivational things that, what's a typical use case, how does this affect backcompat, et cetera, et cetera. Hopefully, most of you all of you use C# 6. Or let's make it easier. Has anyone, and I don't mean to cause any embarrassment, is anyone not reasonably familiar with C# 6? Because you may get confused if we use some of the examples, use string interpolation and things. I've been writing about C# 6 and 7 together for sufficiently long that sometimes I get confused as to which features are in which version. However, we have an agenda here. This is a slightly more detailed version than I normally have because it was going into each feature with the order to do things. I was putting this together in a separate text file and then thought, there's nothing desperately secret here. You know, it's not Bill's social security number or anything. So I just keep it here because it's simpler. Okay. I think that's all and we're good to go. So tuples are the first feature of C# 7. And normally when I would introduce a new version of C# 7, new version of C#, like with 3 and 4 and 5, it would be really easy to say, C# version X is all about this big idea. And really can't do that about C# 6 or 7. And it sounds like probably not with 8, although there will at least be a few big ideas. C#, both 6 and 7, have a bunch of smaller ideas. They're mostly to do with making code easier to write, easier to read, and a few bits and pieces in between. So we'll start with tuples, and I'll show you some code to start with. This uses tuples in a variety of ways. So we have, at the top, var tuple1 equals, and then what's called a tuple literal, and you can see we're pulling things out as item 1 and item 2. Then we can see on the second section that we can also construct it with value tuple and pull out item 1 and item 2. We can use the same syntax as the first part and then pull them out as A and B. We don't have to use var. We can specify the type and the element names in the type declaration, the variable declaration, and then the tuple literal doesn't have to have them. And note that this is assigning to a tuple with a long first element and an int. And we can infer them as we did in tuple 3. Okay, so that's shown you some of the syntax, but what is a tuple? Think of a tuple as an unencapsulated form of composition. So out of interest, how many of you were in my talk this morning? Loads of good talks. It's not a problem if you weren't. So I talked about composition and how it adds value, and that there are lots of different levels of composition. There's just, I want to shove these two values together. Then there's, I'm going to shove these two values together and give them names that imply some kind of greater meaning. And then there's, I'm going to shove these two values together and indicate other operations that you could do. And that's called writing a class or a struct, okay? And tuples have nothing to do with that. But these first two around, I want to just shove a couple of things together in a completely unencapsulated way. I'm not saying anything about the values really. If I give them names, they're more suggestions than fully validated requirements. And tuples allow you to do that really easily. You may have seen tuple of T, T1, T2, T3, etc. in .NET 4. .NET 4.7 introduced value tuple, and it's available as a separate NuGet package.
4.7.
4.7.
I think.
Oh, right, okay.
Well, okay, actually, can I interject something here?
Of course.
There's a .NET Core versus .NET Framework thing, okay? So .NET Framework gets delivered as a Windows update. So you may have heard we do things like the spring update and the fall update. That's when the .NET Framework on Windows gets updated. .NET Core gets delivered whenever .NET Core wants to. So system.value tuple went in the fall creators update for Windows, which is 4.7.1. That was the next Windows release it could be in. On the .NET Core side, it's in .NET Core 2.0. So if you're building .NET Core apps, you don't need the extra NuGet package once you're on 2 on Windows. If you're on a machine that has 4.7.1, then you don't need the extra NuGet package. For any language feature that relies on a type, we'll always have a NuGet package with that type. So we're not going to gate you that way.
Okay.
Okay?
Cool. Thank you. So system.tuple in .NET 4 is a reference type, and I think it's immutable. I hardly ever used it.
I think so. I think it is.
System.value tuple, or value tuple, is a struct, and it's mutable, and it has public fields. Are you feeling scared yet? Okay? These are things that are generally designed to make you run away screaming. When you're writing an encapsulated type, you don't have mutable structs, and you don't have public fields. And in fact, if either of those had been true without the other, it would have been a problem. But the way to think of value tuple is that it is unencapsulated. All it's being is a container, a bag. So when you have a tuple variable, like tuple1 here, well, let's go for tuple3, because it's got nicer names. That's just a bag of fields. It's got an A field and it's got a B field. So it's fine for us to do that. If you're passing a value, you should think of it as a bag of values. So if you have a parameter, everything will have been copied by value. So it's fine for you to modify that, and that won't change the caller. If you have a read-only field that is a value tuple, that's effectively a bag of read-only fields, a bag of values. And it took me a while to be comfortable with this, but I am now. So the reason that tuples were horrible back in .NET 4 with tuple of T were a few big reasons. Firstly, no language support. You do not want to be writing this all over the place when you can write this. Okay? It makes a big difference. Secondly, being able to assign names. No one wants to write item 1 and item 2. In particular, if you ever use tuples with two types that are the same or very similar, if they are int and int, who's going to know which is which? Yeah, my favorite example for doing named arguments in C#4 was messagebox.show, which has title and content, or something like that, title and text. and I could never remember, and I didn't want to have to remember which way round they went. So use named arguments, and you're good to go. Likewise, use named tuple elements, and you suddenly provide a lot more context to anyone reading the code. The computer doesn't care at all, doesn't care about the names, more so than ever before, as we'll see in a minute. Being value types, it means that they're cheaper to pass around. If you want to return 2 values from a method, say you want to introduce a new link operator of min-max. It returns you both the minimum and maximum of a sequence at the same time. That's fine, just return a tuple, no heap allocation, it's all good being value types, and the mutability sounds awful, but it works really well for you to take existing code that has a bunch of fields and just say, do you know what, I seem to have address 1, address 2, address 3, and name 1, name 2. That's clearly 2 different sets of fields. I don't want to bother writing an address class that properly encapsulates things, but it would be helpful to have just 2 fields, name and address, that are then composed. So it's lightweight composition for times when you don't want to bother with encapsulation. It's not saying that encapsulation is bad, but you don't always need it. And this is why I'm not sure whether I've got an agenda item for times that you shouldn't use tuples. I would generally not recommend returning tuples from public APIs or accepting tuples. In most cases, it's going to be simpler to encapsulate this is what my composed value means if it's something that is widely applicable, so you want it to be public.
So this is something we talked about this morning, is deciding when to use a tuple and when to create a class or a struct. And one of the guidelines that I often give is think of someone coming to your code base and reading it for the first time. They're going to look at the names of types you've defined, the classes and structs, and think those are important things and concepts I should understand. Where I'm passing around a tuple, I don't think that's an important concept. It's just values that happen to travel together. So as you're trying to figure out which one do I choose, I'll often look at that. Is this a concept I want a reader to understand later when they read this code? Or is this just values that happen to travel along together?
Yep. And for something like min-max, it would be reasonable to write a public extension that did return tuples, a tuple of the min and the max, because you're not trying to encapsulate anything. But if you find yourself returning a date time and a string, then A, use no-to-time instead of date time, and B, think about, well, what's the relationship between this date and time and the string, and doesn't that deserve a more first-class approach than just, as Bill says, things that happen to go along together? Okay, I'm going to whistle on because it's really easy to spend, and I know from NDC Oslo, to spend half an hour discussing tuples. One important thing, though, is what they look like in the CLR. So, how many of you are familiar with anonymous types? Okay, we introduced them in C#3, fundamental to LINQ, because they let you do lightweight projections with named elements. Tuples are really different to anonymous types. Every time you use an anonymous type in C#, the compiler will generate a new class for you internally. Modulo, same properties in the same order, regardless of types, because it uses generics. But with tuples, that doesn't happen. There are the value tuple types, structs, and those are the only ones that will ever be used. So if I do var tuple 3b equals foo 5 bar 20, then tuple 3 and tuple 3b will have the same execution time type. Okay? The compiler is using those names for our benefit, not for execution time benefit. It's a little bit like if you've used Java, the type erasure in Java with generics, where there's only one real type and it's just useful at compile time to be able to restrict things. That's very similar with types here. In C#, the language, they are regarded as different types, but with identity conversions between tuple types that have the same element types in the same order, regardless of the names. One downside of this, compared with anonymous types, is that if you call toString on it, it can't show you the names. So let me do anon equals new, a equals 1, b equals 2. And then if we write, let's explicitly call toString. Okay, so I will run this code, and then can't remember whether it'll, oh, white background, hooray. So tuple members. So our 3 console.writeLine statements print 1, 2, which is this T1, so that's the X, Y. True for T1 equals T2, even though they've got different names. And anon toString, the anonymous type preserves the names, which it can do precisely because the compiler has generated a new type each time. Okay, so there is that downside to tuples versus anonymous types. But in general, they work how you want them to. You can pass them as parameters, you can have them as fields, you can have them as return values. So here's an example. If we had lots of counters within a type, just have one tuple that keeps all of them, and then we can increment one of them or the other. And obviously, when you've only got one field, yeah, maybe it would be worth having 2 fields instead. But by the time this is a sort of mini encapsulation within an implementation, that these things happen to travel around together, then it's really useful. Right, I want to move on. What have I missed, Bill?
I think we covered most of it, other than,
okay.
I think we're up to deconstruction. Oh, there was only one thing maybe to add on the element names.
Element names,
is
yes.
That with element names, they are burned in metadata with attributes, so they are available publicly, and they are available if you wanted to use reflection to get at them.
Yeah, although getting at them with reflection is interesting. So one of the tricks that the compiler does is you can have as many tuple elements as you like. Hundreds if you want, or at least I haven't run against a limit. Don't, but you can. And you could easily have 12. Value tuple only goes up to 8, I think. The compiler magically uses another value tuple when it gets to item 8. And so if you have 12 elements, that will be a value tuple of T1, T2, T3, T4, T5, T6, T7, value tuple T1, T2, T3, T4, T5. And the compiler just manages all of that, and it manages how the element names are worked out within that, and it's relatively tricky. So I think if you're dealing with reflection and tuple names, expect it to be a slightly rough ride unless there are helper functions available.
No, the more important part about that is if you do have tuples as a public part of your interface, you deliver that DLL, Visual Studio and other tools will read it.
Right, yes. Yes, so you can expose element names in one assembly and consume them in another. That works. Okay, let's segue into, any questions on tuples? It is a huge topic, and it's kind of tricky to cover adequately. I'm aware of all the things that I haven't covered, but think of them as bags. Don't be scared about them being mutable value types, but be aware that they are. And those are kind of the big, don't generally expose them in public APIs, are the key things. And be aware that you do have compiler support for tuple literals. You almost never want to be explicitly constructing things like that. Okay, let's look at deconstruction. So tuples help you quickly compose things. There are 2 language features in C# 7.0 that help you decompose things. One is just deconstruction, and the other is pattern matching. So, pattern matching may be more decomposy in the future. Anyone following along in the Roslyn repo may have seen a load of language designs, because it's great that the C# team mostly works in public now, so we can see a lot of what pattern matching might look like way down the track when we've also got record types and who knows what. But we'll stick to what we've got for at least this talk. So if I've got a tuple, suppose I've got a method that creates the minimum and maximum. So I'm going to pass in a sequence, and I will get back a tuple. That's all very well, but maybe I want separate variables because I'm going to use the min and max quite often. Wouldn't it be useful if I could just deconstruct it to two separate variables rather than one variable that is a composition of fields? Well, for some reason Visual Studio thinks I want to keep seeing system.console. Maybe if I hover over something else? Nope. Oh, go away. Come back. Yay. Right. So deconstruction allows you to declare several variables with something that sort of looks like declaring a tuple variable, but this isn't. This is declaring three different local variables in one go. So I'm calling this create tuple that does whatever it needs to do, and then we have A, B, and C. So if we did write our INumerable int source, okay, I'm not going to implement it now. But if we had min of 0, max of 100, it keeps removing my colon. Bill, I would like you to fix that.
I'm not even touching that keyboard.
No, fix Visual Studio. As the Microsoft employee on stage, you're therefore responsible for every bug in Visual Studio.
I understand.
So using our min-max example that I mentioned but didn't have coded up, sometimes you want to have things separately, and all you've got to do is just say var min-max. And if you want to explicitly type things, you can even mix and match and say, I'll make some of it var inside the tuple, inside the local variable declarations, but I'm still declaring two local variables. So that's a really handy thing to be able to do. Take a composite value that's returned from a method or obtained in any other way, maybe it's a parameter, maybe, who knows, and extract separate variables from it. So if that's a useful thing to do, but we've said, well, if you want to start encapsulating things properly, then, hey, maybe you should be creating a struct or a class. Well, we don't want doing the right thing there to take away functionality later. If deconstruction is a useful thing in general, why would we restrict it to tuples? Well,
I had a question before you get there.
Yeah.
So what if I only wanted the min? And don't just make me call min. I want to just throw away
Bill
the max.
is displaying a wonderful amount of faith in my memory of C#. I haven't mentioned discards. Let's make this min-max bargle, where bargle is some bizarre thing that no one really wants at all. And okay, we call min-max bargle, and all we wanted was the min. So this underscore is what's called a discard. And interesting things happen if you already have a variable called underscore, which is valid, but at this point it's trying to deconstruct to two things. So this is trying to assign to the existing variable twice and declare a new one. I should have mentioned that it would have been fine if we'd had int min equals 10, int max equals 20, and these don't have to be called this. Yeah, they could be foo1, foo2, foo3, it's 30. It's fine to do deconstruction that is an assignment instead of a declaration. Okay, our 10, 20, 30 have gone away now. We've assigned to three things at the same time. And obviously min no longer works. However, before we got to that, I was showing int min and then underscore underscore, where underscore just means I don't care. And this was already a convention that I certainly had. If I had a lambda expression and I didn't care about the parameters, so say it was going to return a random number, whatever, then I would use underscore as the parameter name to mean bleh, don't care. So this codifies that into a discard, and you can see I've got two different discards, both called the same thing. I can't do int ignore, because that would be declaring two local variables with the same name. These discards really are discarded, and I can't even get at them, and that's why there's no type specified. This has not declared a local variable. That was what you were getting at, I assume?
Yes.
Good. So, what do you do if you don't want to be using a tuple for this? So obviously I'm going to use date and time as the example. So what if you've got a date, and we've mentioned at some talk this morning, yeah, it was at my Sondheim talk, how would you represent a date? And someone said, with a year, month, and day. So naturally, if you want to deconstruct a date, you would deconstruct it into the year, month, and day, and maybe calendar system. Well, you can do that with, I do have an extension method somewhere. Sorry, extension method deconstruction. So this is a version of NodeTime before I put this into NodeTime itself. So I have this local date, and so long as I have an extension method or an instance method called deconstruct, so deconstruct becomes a magic name as far as the C# compiler is concerned, that takes a date and has 3 out parameters, then I can do get the current date from our system clock, which does implement iClock, Kevlin. And then I can just assign to YMD, declaring variables called YMD, and obviously I'd normally write year, month, day, but I want to observe that you don't have to call them that. And that just deconstructs. And it's not just extension methods. If you have a regular instance method that can be internal, it could be private if you're only using it through the same, within the same type, you can just do that assignment and it will deconstruct for you. I want to point out one nifty thing here. So this is the this is an assignment to X and message that are parameters from X and message.
So this, can I interrupt? This is something that is incredibly cool, and probably our most loved use of this feature is, let's say you have, no, I don't even need to destruct. No.
I'm going for a constructor as well.
Oh, yeah, there you go.
Yeah.
Now, but you were in the last talk. We wanted to do immutability here, right? Yeah, there we go. So you got all this, and now I can assign that to the local fields in one statement.
Yep.
Because it's a deconstruction assignment of 3 different variables.
And I think that will work even, it really should work even if they're immutable.
Yes.
Yeah.
So now that makes writing constructors especially clear. Take all the things that came in as arguments, assign them to all these fields, but just do it in one statement, please. I really don't want to write brackets and extra stuff.
And in the IL for this, at the moment, I believe it will construct a value tuple of T1, T2, T3, and then deconstruct it.
Yes.
Tuples don't use a deconstruct method for complex reasons that I do go into in the 4th edition of C# in depth, but I don't intend to do here, mostly because I can't remember them right now.
Neither can I.
But, well, for one thing, because there can be tuples, as I mentioned, tuples of more elements than value tuple supports. So it can't possibly support it just through deconstruct. So if you're not going to need deconstruct, why bother? So at the moment, that may be slightly less efficient than assigning it through 3 statements. But I bet if we all start using that and then complain about the performance, they'll just fix it.
I will point out that the team's using that, the C# compiler team's using that all the time.
Right. So yeah, if it's not already a pattern spotted by the JIT compiler, I would really expect it to be in the future, because it's really sweet. And the fact that it's one statement makes it very obvious that that's all that the constructor is doing, is copying from there to there. There's no other work in the constructor. And sometimes constructors could do with doing some actual work, and in that case, let's make that obvious. So, that's deconstruction. You may be wondering why deconstruct uses out parameters instead of returning a tuple of things that it can then deconstruct or whatever. It's the way that overload resolution works. So imagine public, what have I got? Int x, string message, deconstruct, and parameterless. Okay? So this would have been a different design. That's saying we can deconstruct this to a tuple with int and whatever. But in this case, I've got two different deconstruct methods. One that will deconstruct to the int and the message, and another that deconstructs to the int, the message, and the exception. Okay, well, let's see what that would look like. Let's just copy it, and exception, exception. Can you see the problem? We have two parameterless methods that differ only in return type. C# does not like that. Using out parameters, it's fine. We have all those out parameters, which means that in NodeTime 2. You can deconstruct a local date to either year, month, day, or year, month, day, and calendar, and it just depends on how you're trying to use the deconstruction that determines which overload is used. Deconstruct cannot be generic for reasons of type inference gets really, really confused. Even if it feels like you should be able to do it, you just can't. And it does make sense when you look at exactly how it's represented in the language spec for, well, it's equivalent to calling exactly this, and that wouldn't have type inference applied. Sorry about that. It's just kind of annoying in a very, very few cases, but it doesn't hurt the normal use case.
And you said we could go on for tuples for half an hour?
Yep.
We did.
Yeah. Oh, well,
Okay.
We've done all of deconstruction.
That's good.
Yeah. Okay. Pattern matching. So, there are two aspects to pattern matching that are worth separating out mentally, because each may expand in the future in C#, and it's worth knowing, oh, this is just a new pattern, or this is just a new place I can use patterns. I think there are less likely to be very many new ways of using patterns, but there may well be new patterns coming up. There are 3 patterns in C# 7, across all versions, I think. There is a constant pattern, there is a type pattern, and there is the var pattern. And patterns look like this. A value on the left, an is, and then the bit on the right that is the pattern. And you can tell the difference between this and the regular is operator because it's got more than just a type. So this is a type pattern that matches if x is an integer. And it declares a pattern variable, this I.
But you can also recognize that because you can't use the regular is statement with value types.
That's true. In this particular case, you can tell the difference because it's int, and you couldn't use x is int. Yeah?
Yeah, I think so. Or no, it's as you can't use. With,
Yeah. I was going to say, you can check that for boxed ones. Yeah, for non-nullable value types, you can't use as. Okay, so the interesting point, and that's interesting from a language nerd kind of perspective, in that I believe this is what caused the most discussion. Bill's trying to get, right. A few years ago at a conference, Bill and I presented together, and I started editing the code just before he presented it. And this is clearly his time for getting revenge on me. But the interesting bit about I is what the scope is. In particular, can I use I outside the if statement? So we can see here, no red squigglies. I can use I, and this is where you would normally, before pattern matching, you'd have had to do, if x is int, then int I equals, and then a cast from x to int. Okay, this gets rid of that. You are very unlikely to have to need that kind of casting ever again. It's wonderful. So we can clearly use I inside the if block. However, predict as I type, but before Rosin catches up to present squiggles or not, whether I'll get an error for this, and if so, what the error is. Okay, there is an error. Hands up who thinks that the error is that it's out of scope. Hands up those who think it's another error and would be willing to say what that error is. Anyone? Yeah. It's not definitely assigned. Yeah. Use of unassigned local variable I. So we can't use it there, but it is in scope. If I try to do int I equals 10, then that creates an error. A local variable or function named I is already defined in this scope. So I mentioned 3 types of patterns. The type check pattern that says, is this value x a value of the type named here, and if so, please assign it to this newly declared variable. And it becomes definitely assigned if we can only get into the, because we can only get into this if block by that being true, that's fine. So I can do x is long other. Okay, this is now valid but useless code because something can't be both a long and an int, but I is definitely assigned. If I try to do or here, then I can't use I because that's not definitely assigned, because maybe I is assigned and maybe other is assigned. Kevin? Why what?
It's because it's an if, is the problem. Is that I could write something up at the top that goes if not x is int I, and I need I to be in scope in the else clause.
So if I write a for loop which has an in counter, and then I use one of these in addition,
I think so. Is different than, yes. Yeah.
So the awkwardness that Kevlin is describing, right?
This is also ugly because you need that variable in the else clause, and it has to be in scope.
For object j is null, if j is int Kevlin, no, nothing in there, then we can't declare oh no, do you know,
yeah.
That's interesting.
Because
here, we're not allowed to declare Kevlin higher, whereas earlier on it was complaining about the later declaration. So you can't do it, but
for different reasons.
But for the different reason that the compilers decided that the earlier declaration is the invalid one.
Well, okay, so there's a reason for that, and this gets to the idea of C# helping you write correct code. So first, scope is a compile time construct, right? And initialization is a runtime concept. So I need you to move the cursor just a bit.
Yep.
So the scope of Kevlin here is the entire method, right? Because it's declared in the method. Any place above this declaration, it is uninitialized, right? Because we haven't gotten there yet. But it's declared, its scope is the whole method because of where it is in braces.
That sounds great, but the scope of I is the whole method. And it's
Down
that
here.
one that's complaining.
Yes. The scope of the other I is the whole method as well.
Ah, right, okay.
it's a statement.
Yep.
Is it not scope to that statement? Let me just put it this way. C++ got this one right.
Yes, I know.
Right. C# is getting it useful.
No, that's a different one.
I would love to give an example. I have used a counterexample, but I can't remember it right now, and that makes me very, very sad.
I would like to move on, I think, because
Yeah.
this is a deep rat hole, but it does.
It's
Right.
it's the
but
rat hole that
what
the
it really
C#
works
team
on
went through.
is
Yeah.
if I were to have an else clause here, I really want things declared in that if to be available in the else.
It's still the same statement.
No, it's not. It's a different. If it's a different scope, because that one is only true, and that's why you have to move it out
Right.
of the if statement.
And actually, I've got the example now. Throw new exception. You can only pass ints. And then, okay, that's where it's useful.
Yep.
I want to be able to test for something and use the result of that test later. And it could be that the if is a different one, and I want to be able to use it from the negative case. Yeah, it would be annoying to not be able to do that. But don't feel bad about, the C# team spent months trying to work out whether this should work or not.
Which means they're going to spend months handling responses.
Yes,
Yeah.
we are.
Yeah.
We already have.
Yeah, there you go.
Okay.
But let's look at one example that I brought up
Oh, yeah.
just a bit.
Which one
Go
is
up.
this? The
Lines 16 and 17.
right.
What should
Ooh.
happen there?
So, I'm going to guess. So when we get to object X, this doesn't know that it was originally via a nullable int, because nullable int is just boxed as an int. So yes, it will print, hey, you passed me 12. What's interesting is, what if we do that? That's still valid.
Yeah.
And that can detect, that's basically saying, did you pass null or not? And that's a really bad way of saying, did you pass null?
Bad way to do it.
Right equals null. Speaking of really bad ways of passing things and checking things, let's look at the next kind of pattern. This is the constant pattern. So we still have is, but it's saying if x is 5. Okay, no one should ever write that code unless they're demonstrating the constant pattern in this case, because we know that x is an int. So this is exactly equivalent to that. That's the better way of doing that. There is a reason for using this kind of pattern, which I'll show you when we talk about switch and case. Here's a slightly less pointless version, where we're passing in an object, or a reference, and now we're saying, is it 5? And now the question is, under what situations, under what circumstances is that true? So here are some examples. We're going to call it with 10. Don't expect that to print, that you passed in 5. 5, would expect that to say you've passed in 5. 5L, the long 5. And passing in a string. No, that's not equal to 5. And let's just give us one more, just to, if we're going to do a string, let's try the string 5.
Oh, good Lord, man, you're writing JavaScript.
Yeah, exactly. So this is where, I don't know what the VB version of pattern matching does at this point. Who knows? So the interesting one here is 5L. And without wishing to, this is for my interest, how many of you think that this should say, yep, that's 5? Okay, and how many of you think it shouldn't be 5? Okay, and about a quarter of you didn't put up your hands. Fine, it's fine. So we've got 5 things here. Oh, there are build errors. Oh, that's because I've done all kinds of, let's just remove all our, undo everything from there. I love change control. Okay, we are now building. So if we do pattern matching 1, oh, okay, we screwed up our pattern matching thing for Kevin's sake.
It's all his fault.
Of course. Good, thank you. It's always good to have a helpful audience. Right, pattern matching 1. Okay, so we previously did a few checks before. 10 isn't 5. 5 as an int really is 5. but 5 long isn't 5. So it really is checking both the type and the value. And if we made it x is 5L, then it would be, those two would be reversed. And no, a string value 5 really isn't an integer 5, which I think we can all be grateful for. Okay, so the third kind of, I haven't got.
I think we need to go into switch to really have a good example for that one.
So var will help more. So we've seen that you can use patterns. Remember, kinds of pattern you can use, places you can use patterns. You've seen the places you can use patterns as if statements. And I think you can just do Booleans as well, just a Boolean expression.
It's just an is expression.
Yeah.
So you can use it any place you would want to do that.
You can also use them for switch case. And we've currently seen type and constant patterns. Switch case is where constant patterns become more useful and where the third kind of pattern of var comes along. So, previously, switch statements have always had to have cases that are constants. And those constants have had to be distinct, so there has never been any opportunity for more than one case to match. Okay? Unless you consider default as always match, and it will sometimes match other things as well. Now, switch statements, the order matters. So we're taking some object in, and we're saying if we were given 5, which we've already seen will be only when it's 5 as an integer, we'll return 5's never blend. If we're given, these are the same condition twice, for the sake of the comment, basically. So 2 case labels for the same case block. That's as normal. But there's an interesting thing here, which is I can't use y or z. If we only have one pattern variable, or rather one case statement, so there's only one case label that can have matched, so y is definitely assigned, then y is introduced. Really interestingly, we can have another case label for y, or rather that introduces a pattern match for y, just for any int, and the scope of that, the scope of any pattern variable introduced by a case label is that case block. This is not the same as if we declare a variable. So we have, no, let's not call it x. Let's call it local. If in some completely different case label we try to write the value of local, it will say it's not definitely assigned. It is in scope. This is bizarre and basically, I think, a failure in the C# specification, but it's far too late to fix. Okay.
There's no good way to fix it.
There's no good way to fix it now. Basically, case labels should have required braces all the time, at which point it would have just been solved by all the regular rules. Early versions, in fact, I think currently the MS spec claims that you can reorder case labels however you like. You couldn't before because of this, and you definitely can't from C#7 because of patterns. So these take precedence in an order. So literally, the generated code will... Sorry? You can put curly braces if you want, absolutely. Yep. So first it will check whether it's 5, then it will check whether it's divisible by 5, then it will check whether it's an odd number, then it will check whether it's an integer. So if you pass in 5, then every single one of these case statements, these case labels will match, but it's the first one that takes priority. There's one exception to that. If you give a default, that default is always effectively at the bottom. Now, it's not compiling because of the var case, which I will explain in a minute. But the fact that this is at the top is irrelevant, and therefore I would strongly recommend that you always put it at the bottom so you don't need to remember this. Okay? If your convention is it's always at the bottom, then it's obvious that it will only happen if nothing else matches. The final kind of pattern, and the one that's more useful in switch case than in if statements and things, is this var, which is kind of like a type pattern, except it matches everything. So it ends up with a static type, which is the same as the thing that you were switching on. So if you were switching on an IFOO, then the type of O would be IFOO, because it will definitely be at least that good. What have I done wrong?
No, just
We've got object for the moment. Yeah.
In this case, it's object.
But we could make it I-comparable in this case, and it's still fine for those various ints. And then O will be you won't be able to see this, but that really does say local variable I-comparable O. So this is like a default case, except you get to use the variable afterwards, which isn't terribly useful if you're just switching on X, but if you are switching on some large expression, then you don't want to have to evaluate that expression twice, or have a declared local variable above. It just lets you say, match something and capture it. Okay.
Now, to be fair, though, I think you can put a when clause there.
Yes. So I didn't even introduce the when clauses. These are what are called guard clauses. When datetime dot now dot hour minute less than 14, because we really need to move on before it gets to 5:14. So yes, you can. A var clause without any guard will always match, even if it's null, unlike anything else that does type matches. But you can put these guard clauses, and that can be an arbitrary expression. That can also have more pattern matching in, which will declare more, which can declare more pattern variables. So you can capture more than one pattern variable in one case label.
You did actually gloss over something really quick there. That's really important. If you look at this case, string name, when name.length is greater than 5, we don't need to check against null there. Okay? Even if the type up at the top that we passed in was a string, this pattern only matches if it is non-null. There must actually be storage there.
Which is just like the is statement, as you'd expect. If O is string, checks that O is not null as well. Okay, we're rapidly running out of time.
But this is fun.
It is. Well, that's the trouble. It's always fun. Local functions. Basically, you can now use declare functions inside, or declare methods inside other methods. So here we have a way of doing the Fibonacci sequence. I should have done a Fibonacci version that uses tuple deconstruction and assignment, because that's a really nice way of doing it. But this is just calling fib from within main. Outside main, fib does not exist. And you can sort of mock that up a little bit with delegates, but it's really annoying. It gets more than annoying when it comes to capture variables, though. So a local method is allowed to capture variables just like a lambda expression can. But the difference is the generated code, if you capture variables and you don't do anything with the local method that would potentially prolong the lifetime of those captured variables, like converting it into a delegate or something like that, then the compiler can do cool stuff to make it really efficient. Instead of generating a class with all the captured variables, it generates a struct that it keeps on the stack and then passes that by reference to the method instead of anything else. I have used local functions successfully within code to break what would probably be far too long a method to be one method, and would be annoying if I'd had to create private methods because they would only be called by another method, by this one other method. I've moved those private methods into the method as local methods. So you end up with something that, yeah, looks like it is overall quite a long method, but it's really nicely broken down within that. I'll give two examples of the same kind of usage, which is another really useful thing, which is for anything with an iterator block. So anytime you're using yield return, or probably more likely these days if you're writing an async method. Do I have an async example? No. Both iterator blocks and async methods have a problem with validation. If you call foo async null, and the first line of foo async is, if the parameter is null, throw new argument null exception, what will happen? It will return a failed task. It will not throw an exception. And that may be OK, but I like validation exceptions, the you've done something stupid when you were calling me exception, to happen as early as possible. There's no reason to wait for that to complete, to wait for someone to wait for that to complete before finding the error. Because by that point, you may have lost some of the context of where things went wrong. Likewise, exactly the same kind of validation with yield return. If no one evaluates the sequence, then we never even execute any of the code. This is an example of what it's like when it's broken. Previously, the way to fix this would be to write something that doesn't have any yield return, or a non-async method that still returns task of t, do all your validation, and then return the result of calling an implementation method. And the point of using local functions is you still do that, but it's your local function that is the iterator block or the async method. So you get to hide it. You're not polluting your scope, even with private methods that nothing else is ever going to need to call. OK, given the time, Bill, anything else on local methods?
That's about it.
OK.
It's generally a pretty simple feature. Yes, question there, though.
Sorry, do you have to declare local methods?
Nope.
You don't, right?
No.
So you can declare local methods. You can declare local methods within a for each block, void print item, console.writeLine item. This is just using a method, expression-bodied method for simplicity. So you can do this. Please don't. You've got to declare it within here, otherwise you don't have access to item. But it looks really weird and painful. So I would try not to do that. One restriction that I hope to persuade the team to fix at some point is local methods have to be unique by name. So there is no overloading. Before now, I have wanted to write 2 different overloads of the same method name as local methods. That's not allowed. They contribute to the same declaration space as local variables and each other, so everything has to be unique. That's kind of annoying occasionally. OK. So I think we're about halfway through the agenda now.
This is awesome. Actually,
I will leave reflocal and refreturn entirely to
I will
you, if
talk
that's okay.
about
Cool.
that more in the next.
OK, because I can cover the last 3 in about 2 minutes, which is good, because I have 1 minute. So, custom async return types. In C#7, you can write your own task types that can do all kinds of funky things. You will never need to do this.
So I have a question. Does anybody think they do? Good, you guys are smart.
OK, so this is, instead of returning task of t from an async thing, you could return build task of t, so long as you have a build task factory that does all kinds of cunning stuff that's really complicated to get right and thread safe. Or you can use the 99.999% case of value task of t, which is a struct which is stack allocated unless it's actually not completed. It was basically built for ASP.NET Core. It will be useful outside ASP.NET Core as well. The crucial thing is, if you're fetching a value from a cache, and most of the time you will hit, but just occasionally you need to make an async call, you've got to return something that is awaitable, because it's fundamentally asynchronous, but you don't want to take the hit of allocating a task on the heap on every one of those calls if it's just returning, hey, I've got the value. Oh, you've put me into a state machine. OK, now I need to do a state machine dance, and it all gets very complicated. So value task of T is purely an optimization aspect, and it is basically the only implementation of task-based types that we'll ever need. I may try to come up with some weird and dangerous ways of doing things, but I don't expect anyone to do it in prod code. Throw expressions. Throw is now an expression in some cases, but not all. There are two reasons you may wish to do this. One is this exact code. So basically, I have preconditions.checkNotNull all over the place in various libraries. You could do if value not equal to null, return value, and then throw new argument null exception. But hey, we've got the null conditional, sorry, the null coalescing operator, so let's just use it. Likewise, a lot of people don't like this code, so if you don't, you're in good company. But I find this sort of nested conditional operator, ternary operator, it's the conditional operator. I find this really readable. So condition, if the condition is met, return this value. If that condition is met, return that value. It's sort of a poor man's switch case. And yes, you could use pattern matching, but sometimes you really don't need to. And being able to throw at the end, that relies on throw being an expression. What I would really like, instead of doing this, is to have a simple way of expressing pattern matching as the return value from this method is the result of matching this pattern, because then I can pretend I'm writing F#. And finally, numeric literals. You can now write binary. Woohoo! You can now use underscores. Those underscores can go anywhere. You can even have multiple ones together. And when I say anywhere, I mean, of course, anywhere apart from the useful place. So wouldn't it be nice to be able to separate the OX part, which has nothing to do with the value, it's just the base, from the number itself, like that?
I got a sample for you.
Yeah.
Just wait a few minutes.
OK. I won't spoil the surprise then. So numeric literals, you can write literals that are slightly more readable. That was the incredibly rushed version of what's in C# 7.0. Hang around for 20 minutes, or grab a coffee, and then hang around for 20 minutes for what's in 7.1 and 7.2. And rather than taking questions now and everyone feeling guilty for sort of getting up, come and see us on the stage. Thank you.